Section 2.4, homework problem number 2. Explain in detail why we determine which of two fractions is greater by giving two fractions common denominators. So this is one of the methods of comparing two fractions. So first we need to explain why we give them common denominators, and then we can compare which one is bigger or smaller. What is the rationale behind this method, and also what are we really doing when we give them common denominators? So we did I did give examples in class, so I may just explain here and ask you to write down in your own words. So the example I did in class was well, this was one of them which already have the same denominator, and notice that if two fractions have the same denominator, say 7 and 7 here, they, by the definition, each of size 1 7, each of size 1 7. So each slice, each part, if they have the same size, all we have to compare is which one has more parts, more number of parts. If, for example, 4 7 has 4 parts, which is bigger than 3 parts. That's why 4 7 is bigger than 3 7. Because the reason we can just compare the numerators because the denominators are the same, which tells us the size of each part must be the same. So whenever we can compare fractions, we have to compare two things. Which two things? Number of parts. Which one has more number of parts? Also, the size. Do they have the same size? If they have the same size, we just need to compare the number of parts. Now, so the one we did, if they have different denominators, for example, 3 and 4 and 5 6, when they in this example, because they have different denominators, we cannot compare them directly. But once we convert them to fractions with the same denominators, again, that means they have the same size. Each part has the same size. Now all you have to compare is which one has more number of parts. Okay, so in your explanation, so first of all, you will need to explain how do you compare. So you need to mention, so I'm just going to list a few key points here. So you need to mention the common denominator indicates that they have, well, you could just say what I did in the slides, they have like parts. So right here, so both fraction have like parts. So if they have the same denominator, so they both have like parts. Or if you want to, you can just say equal size parts, same size parts. The second thing you need to compare is the number of parts. So here you need to mention the size of the parts, and they're the same, and then you have to compare the number of parts. Okay, so the common denominator tells us both fractions have like parts or same size parts. Then we only need to compare which one has more parts, which is determined by a numerator. Okay, so the rationale behind this method, I guess these two parts is pretty much the same. You can just address to these two, and the size of parts and the number of parts. Now, what are we really doing when we give them common denominators? Because originally, if you have two fractions with different denominators, like this one, 4 and 6, because that means 3 parts each size of 1/4, but 5 parts each size of 1/6. We cannot compare them, although this one has 2 more parts than 3 parts, but the size is smaller. It doesn't guarantee more parts will be bigger. So that's why we cannot compare them. But once we turn them into the common denominators, 12, so both of the 9 parts each of size 1/12, 10 parts each of size 1/12. So now they have the same size parts now. So when we convert the fractions with different denominators to the same denominator, we are creating like parts. Okay, So that's what you would have to say. We're creating like parts. So that would be what we're really doing here. Okay, so I guess I can put that part right here. I guess I'll let you write it down instead of just giving you the answer directly. Okay, so next